Okay, let's start. Notice that the question asks you to show that the size of the population decreases at a rate that's proportional to the size of population. So it wants to show the rate dn over dt is proportional to the population. So what we do is that we find dn first. Since n equals to n naught e to the power of minus kt, we can look for dn over dt should be n naught minus k e to the power of kt. And if we rearrange it, equals to minus k n naught e to the power of minus kt. Notice that this part, n naught to the power of n naught times e to the power of minus kt is in fact n. So we can say it's minus kn. And that's it, dn over dt. So the rate of the change here is proportional to the total number. So that's part 1. Part 2, it asks for the value of n naught and the value of k. Firstly, n naught, that's quite straightforward. N naught, that's the initial population, which happens when t equals to 0. So we just substitute 0 back into the original equation. Minus kt. And n, notice in the question that says the size of population is 2000. So 2000 equals to n naught e to the power of minus k times 0. Obviously, minus k times 0 is 0, e to the power of 0 is 1, so n naught is simply 2000, which you can tell pretty much without actually going through the steps, but this is just show you how it works. And now to find k, another clue in the question is that t equals to 3 and the population is 1800. So substitute these numbers back into the original equation. We have 1800 equals to n naught is 2000 e to the power of minus k times 3 this time. And we just rearrange it and solve it algebraically. Equals to e minus 3k, and we take a log of both sides. So 0.9 equals to log e minus 3k. And we have log 0.9. Since log e cancels itself out, so we have equals to minus 3k, and k equals to log 0.9 over minus 3. To work it out, so we have log 0.9 over minus 3 equals to so log 0.9 over negative 3 equals to 0.3, so it approximately equal to 0.03512 something. And then we do need to save this. So because what you don't want is to use incomplete, since it's exponential. Small changes in the power may lead to big difference in the result. So you always save the k value instead of writing the approximations. And the last part, how many years will the kangaroo population have? So look for t, so sorry, third part, for a t when population n equals to 1000. And in that case, 1000 equals to initial population e to the power of minus k t. So 1000 over 2000 equals to e to the power of minus 0.03512 something something t. And again, we just log both sides, equals to log e minus 0.03512 t, and the log 0.5 equals to minus 0.03512 t, and we have t equals to log 0.5 over minus 0.03512, which gives t equals to log 0.5 over, shift, recall this number, and it gives us about 19.73, so approximately 20 years. So here is the complete solution.